We're now going to look at some wave terms. The first term we're going to look at is the wavelength. The wavelength is the distance between the centers of two consecutive crests or compressions, or between two consecutive troughs or rarefactions. This is defined as the wavelength. Remember, the crests and troughs you'll find in the transverse wave, and the compressions and rarefactions in longitudinal waves. The wavelength symbol is represented by the Greek symbol lambda, shown here, and the unit of wavelength, the measurement, is in meters, m. The next wave term we're going to look at is the period of the wave. The period is the time taken for one complete wave to go past a certain point is called the period of the wave. The period symbol is a capital T, and the unit of the period of a wave is in seconds. How many seconds it takes for one complete wave to go past a certain point. The equation is T, which is the period, equals 1 divided by lowercasing f. This f represents another wave term called the frequency. Now the frequency is how many complete waves pass a point in 1 second. So it's the number of complete waves passing a point in 1 second is called the frequency of the wave. So the frequency symbol is a lowercasing f. The unit is a hertz, capital H, lowercase z, hertz, or it can also be said to be per second, which is a second to the negative 1. And you can see the formula here, frequency equals 1 divided by the period, t. Now remember, t is in seconds, and therefore frequency is in seconds to the negative 1, or per second, and per second is also defined as a hertz. It's important to know the difference between the period, which is the time taken for one complete wave, and the frequency, which is the number of complete waves passing a point in 1 second. Let us continue with more wave terms and revising the wave terms from grade 10 work. The speed of the wave. Remember, the speed of the wave is the distance in meters moved by the wave per second. So we have speed equals distance in meters divided by time in seconds. The symbol in this case is V, and the unit is meters per second, or meter seconds to the minus 1. Now remember, speed is equal to the product of the wavelength and the frequency. That is the general wave equation, that V equals frequency times wavelength. You need to revise this from grade 10 work. The speed of the wave equals the frequency of the wave times the wavelength. Looking at the solution to challenge number 1. First of all, the speed of sound in air is 343 meters per second. And the time is the time taken to the cliff. Now remember here it is 4 seconds. The question did say that the echo takes 8 seconds to return to the ship after hitting the cliff. One must remember therefore, if it is 8 seconds to return to the ship, it is 4 seconds from the ship to the cliff and 4 seconds back from the cliff to the ship. So the echo is 8 seconds, but we have to use the time taken just to the cliff, and that is 4 seconds. We then use the equation that velocity or speed equals distance over time, and the question asks for distance, and therefore we make distance the subject of the formula equals speed times time. The speed is substituted in 343 meters per second, and we times by 4 seconds, and we solve for the distance, and therefore the distance from the ship to the cliff is 1,372 meters. It's important to practice as many examples like this as possible. And we've come to the end now of this presentation and this DVD. And remember now we can find some additional challenges that you need to practice in your Study and Master book, Grade 11, Learner's Book. These are found on page 81, Activity 4, Measuring the Speed of Sound in Air. Activity 5, Applying the Properties of Longitudinal Waves, on page 85. And Activity 6, Considering the Effects of Earthquakes, page 86. It's important to understand all the concepts in this section on longitudinal waves and sound and the properties of sound. So remember to practice lots of examples and, importantly, to have fun with physics.